This video is on solving quadratic equations. Recall that a quadratic function is f of x equals ax squared plus bx plus c. The related quadratic equation is ax squared plus bx plus c equals 0. To solve this equation means to find the values of x that make this equation true. These values can be called solutions, zeros, roots, or x-intercepts. There are four ways to solve a quadratic equation: by graphing, factoring, completing the square, and using the quadratic formula. To solve by graphing, we want to graph the related quadratic function, then identify the x-intercepts. These are the points where f of x is equal to 0. To solve by factoring, we want to factor the quadratic expression ax squared plus bx plus c, then set each linear factor equal to 0 and solve for x. To solve by completing the square, there are several steps. We want to move the existing value of c to the right side of the equal sign. Then we need to find the value of c that makes the left side of the equation a perfect square trinomial. And that value of c is 1/2 of b squared. Add this number to each side of the equation. Then, because the left side of the equation is going to be a perfect square trinomial, it will factor into a binomial squared. Then take the square root of each side of the equation and solve for x. To solve by using the quadratic formula, we're going to use the formula x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. The discriminant of the quadratic formula is the value b squared minus 4ac. The value of the quadratic can tell you the number and types of solutions to the quadratic equation. So if b squared minus 4ac is greater than 0, that is, if it's a positive number, then the equation has two real solutions. If b squared minus 4ac is equal to 0, then the equation has one real solution. And if b squared minus 4ac is less than 0, that is, if it's a negative number, then the equation has no real solutions. Let's try this example together here. We need to solve x squared minus 6x plus 5 equals 0 by graphing, factoring, completing the square, and using the quadratic formula. Then we're going to identify its discriminant and explain what this tells us about the number of solutions. So let's go ahead and start by graphing. To graph this, I'd like to find the vertex. So recall that the x-coordinate of the vertex is the opposite of b over 2a, which is going to give me 6 over 2, or x is equal to 3. The y-coordinate of the vertex is what I get when I plug 3 into there, so 9 minus 18 plus 5 is going to give me negative 4. So my vertex is going to be the point 3, negative 4. And I know that since a is positive, this is going to open upward, so I'll just make a simple table of values here. So 3, negative 4, and I'll do 2 and 1, and 4 and 5. And remember, we're looking for what is the value of x when y is equal to 0. So when I plug in negative 2, I get negative 3, and I'll get the same thing for negative 4. When I plug in 1, I get 0, and I get 5. And I plug in 5, I'll also get 0. So let's go ahead and graph that. 2, negative 3, and 4, negative 3. 1, 0, and 5, 0. So my solutions are going to be x equals 1 and x equals 5. And I can tell because that's where the graph of the related function crosses the x-axis. Notice it's also where y is equal to 0, which makes perfect sense. That's when x is 1 and x is 5. To solve this by completing the square, give myself some space here. So I have x squared minus 6x plus 5 equals 0. First thing I want to do is move my existing value of c to the other side. So I have x squared minus 6x equals negative 5. Now I want to find a new value of c that makes this side of the equation a perfect square trinomial. To do that, I'm going to take half of b and then square it. So half of negative 6 is negative 3. Negative 3 squared is 9. So I'll add 9 here and add 9 here. Now this is a perfect square trinomial, and it will factor into the quantity x minus 3 squared, and that's equal to 4. And now when I take the square root of both sides, I get x minus 3 equals, square root of 4 is 2, but I need to consider the positive or negative square root of that number, so plus or minus 2. So that gives me x minus 3 is equal to 2, or x minus 3 is equal to negative 2. And adding 3 to both sides, I get x equals 5, and adding 3 to both sides, I get x equals 1. So you'll notice I got the same answers as I did above, but this is by completing the square. The other way to do this is by factoring. So x squared minus 6x plus 5 equals 0. Factor that into two binomials. So I'm looking for two numbers that multiply to 5 and add to a negative 6. So that's going to be negative 1 and negative 5. Now each of those linear factors, because I'm multiplying the two of those and they equal 0, then they need to, one or both could be equal to 0. So x is equal to 1 and x is equal to 5. And my last method is using the quadratic formula. So in this case, notice that a is going to be 1, b is negative 6, and c is 5. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And all of that divided by 2 times a. Or x is equal to 6 plus or minus the square root of 36 minus 20 is 16 over 2, which is 6 plus or minus 4 over 2, which means x is equal to 10 over 2, or x is equal to 5, or x is equal to 2 over 2, and x is equal to 1. So again, we got that x is equal to 1 and x is equal to 5. So these are the 4 different ways that you can solve a quadratic equation. You can solve by graphing, finding where it crosses the x-axis. You can solve by completing the square. If the expression is factorable, you can solve by factoring, and the quadratic formula always works. The one thing we didn't take a look at is the value of the discriminant, which is b squared minus 4ac. And in this case, we actually had that. That's the value here underneath the square root. We found that the value of that was 16, which is a positive number, so that tells us that we have 2 real solutions to this quadratic equation, which is actually what we saw. So the value is 16, and it tells us we have 2 real solutions. So in this video, we took a look at the different ways to solve a quadratic equation.